Hello everyone. This question is related to electrostatic force due to charges. The question goes like a point charge Q is placed at the center of a uniformly charged ring of total charge Q, capital Q. Two small pieces, each with charge Q dash, are removed from the ring, as shown in the figure. Find net force on charge Q due to the remaining ring. Let us solve this question. This is more of a conceptual question. For convenience, I have made the diagram over here. Q dash charges were removed from the ring from point A and point B. Nothing is given about the radius of the ring. We have assumed that this is R, capital R. Capital Q is the total charge uniformly distributed on this ring. So what is happening? You know that in an uniformly charged ring, the electric field at the center be 0. So if the charge Q dash from point A and Q dash from point B were not removed, the total electric force here was 0. So there was no force acting on the point charge kept at the center. Now in the question, they are saying that this Q dash from point A and this Q dash from point B has been removed. So what will be the remaining? What will be the force exerted by the remaining ring on this charge small q lying at the center of this ring? Since Q dash from point A and point B has been removed, so an electric field will develop at the center of the ring, and that will exert the force on the point charge Q. So let us assume, or let us say, F1 be the force due to the remaining part of the charged ring on Q, small q. F2 be the force due to this point charge Q dash which has been removed from point A, and F3 is the force due to Q dash removed from point B on the charge Q. So from the Coulomb's law, we know that if we take all the charges as positive, so from the Coulomb's law, we know that Q dash Q will have a repulsive force and Q dash will exert a force F2 in this direction, that is negative of the y-axis, and the point charge removed from Q dash from point B will exert a force F3 in this direction, negative of the x direction. So since due to the entire ring, when there was no charge removed, the force on the point charge initially was 0. So we have written F1 plus F2 plus F3 is equal to 0. Since electric field at center due to uniformly charged ring be 0. So we are getting here F1 is equal to minus F2 plus F3. This is in the vector form. So if we take the magnitude, it can be expressed as equation 1. From Coulomb's law, the force acting between 2-point charges we will apply here, and we will get F2, that 1 by 4 pi epsilon naught Q into Q dash divided by R square, R distance away. And since it is acting in negative of the y directions, so it is j cap, negative of the j cap. This is equation 2. Same way for F3, we'll be getting this in the negative x direction minus I cap. So from equation 1, 2 and 3, the magnitude of F1 can be obtained F2 square plus F3 square under root. Why? Because these forces are perpendicular to each other. F2 and F3 are perpendicular to each other. So resultant F1 will be F2 square plus F3 square under root. Upon solving, we will be getting this square root of 2 1 by 4 pi epsilon naught Q dash by R square. Since in the question nothing has been given that net force, so if in the exam the question comes, you should also show the direction of the force, this F1. And that direction you can easily obtain from F2 and F3. You will get a resultant in this direction, and negative of this will be the direction of F1. So hope you understood this question and the way it has been solved. So these questions are conceptual questions, but very useful to know. Any doubt anywhere, please write it in the comment. I will explain. Thank you.